Hi roboticists! Today we are going to code a pick and place application with Universal Robot 5 with a robotic gripper. And as always, we are doing it without using any template and plug and play solution, but we will go through all the mental process that leads you to the deployment of your own solution, especially in the industrial field. So, for those who don't know me, I am Francesco from Learn Robotics with Ross. I am the creator of this channel and I am a robotics software engineer and a PLC programmer. The scope of this channel is to learn how to program robotics using the ROS framework or robot operating system. So the approach, as you might already know if you have already seen my video, is to not use a plug and play and a ready solution, but we try to deeply understand what, why and how we are programming our robots in a certain manner. So in such a way to give you all the instruments that you need to deploy your own industrial robotic application. So in order to be reliable for the company that you are working with. So, if you wanted to get into this wonderful transformation and master your career in robotics, make sure to subscribe to the channel and we will do it together. And as always, feel free to book a free call with me to tell me about your robotics needs or technical issues that you are facing in developing your own project for yourself or for the company you're working with. And now let's get started. Okay, here we go. This is my catkin workspace. There are a lot of packages, but for the scope of this video, the most important thing that you need to know is the Universal Robot Gripper Move It config that we have created in the last video. I'm gonna put the link in the description down below and it's popping up at the top right corner. And then we are gonna use the Cobot inverse kinematics package. I have done already several videos on that and I'm gonna provide the link in the description down below. So my approach and then this is the Universal Robot app underscore YouTube, which is the package that we have created in the last video. Okay, so now let's dive into it. Okay, so the first thing that we need to do is to launch the Universal Robot Gripper Move It config demo launch file. We are gonna do that because before to run in a simulation in Gazebo is always a best practice to code your application in C++ and use ROS visualization tool to check if the code actually works and the robot makes what is expected to do. So we have already seen it. So this is the planning group. So we have the manipulator here, which is our Universal Robot Model 5, and this is the gripper from the company Robotic that has provided the, let's say, the hardware description and all the meshes that we need. Okay, so let's go in the upper position to the manipulator. Okay. Okay, so now let's think about the approach of running into a pick and place application. So let's say that to simplify the problem, let's say that we're gonna have a table here in this position with a pieces, just a rectangle that needs to be picked and placed in a certain place here where it's gonna be another table. Okay, so to do that, we will need to simulate somehow the object that we want to pick, and so we can get the position and the orientation of the end effector that will allow us to pick the object. So let's simulate this, and we're gonna simulate, for example, a box, yes, of yeah, this is okay, this is gonna be 0.2 meters, this is gonna be okay. To start, this is a box, okay, and let's move in position x 0.5, then y 0 and z, okay, and z 0.1. Okay. Okay, then what we can do is to get an object of this dimension. Okay, is going to be appear here, and let's put it on top of it. You can use the arrow here, or if you want to be more precise, let's use the positioning tool. So we are saying that in x this is gonna be in 0.5, then 0, and here is gonna be 0.3. Okay, perfect. Okay, so I want to point out something. In this particular case, we are gonna have the origin of the base link, the base of the robot. So let's put it 0.1 and length. Okay, so we're gonna have the origin of the frame of the base link that coincide with the frame of the word. Okay, so we need to know that with this frame in mind, this is gonna be the positive x, this is gonna be the positive y, and this is gonna be the positive z. Okay, so now if we want to code a pick and place application, we need first to pick. So we need to find what is going to be the orientation of the position of the end effector of this robot. Usually in the industrial field, what you're going to do is to just pick with your hands the end effector and place where you want to place, and we are going to simulate using the tool of move it, And after that we are satisfied with our result, our position, the orientation of our end effector, we are gonna check with the transformation echo. We are gonna see in a while what will be the position and orientation of the end effector related to the base link of our robots. So let's place the object in a position that we want. Okay, so let's say that this is where we want our end effector to be at for picking. And we can check this position and orientation by running an important tool that is going to be this one. We're going to use the transform, and the transform says you over the time what is going to be the position and the orientation of one frame respected to another. And we are interested in what is going to be the position orientation of the end effector of the manipulator that, if you remember, were from the Universal Robot 5, the end effector is going to be the tool 0, is named tool 0, related to the base link. Okay, and of course, I want to point out that then we will need to get an offset, I will say, in the negative y, because we have the let's say the physics, we have the space of the gripper itself. So let's run ros run, then it's gonna be tf, then the tf echo function of what? Of base link of the tool 0. Okay, so the result here is related to this position. And then if we are planning and executing, we should see that here is changing. Yeah, it seems to do a weird path planning. So I remember you that this is gonna be a collision object. So is the path planning that is gonna do is supposed to do not touch and avoid a collision of this object that we have created in our scene. Okay, so let's check it. Okay, so this is gonna be the position and of the tool 0 related to the base link. And in fact the position is gonna be in x 0.5, yes, we are here, and minus 0.1 and y 0.3. Okay, yes, and this is gonna be the orientation. Okay, so feel free to play with your end effector and find what is gonna be the position and orientation of your end effector related to your base link of your robots. So we are gonna, let's say, save this data, and because we will need it to use as a target position for the picking. Okay, so let's close. So now let's open this package here and let's code a pick and place application for universal robots. So I have already tested before. This is gonna be this one, but don't worry about that. So we are going to, as I promised, pass through all the mental process that you need to do to deal with the solution. So we are we are creating another file. Let's call it universal5 pick and place. Let's say that is gonna be for YouTube purpose. Okay, an important thing that I wanted to point out is that we already done this kind of video, but with another robot, with a custom design, with a very rough cylinder. So this will be very important. And I'm gonna put the link in the top right corner. So actually what I'm going to do is to open that file and so in order to allows you to see how the powerful of ROS. So you have coded once and then it will be very simple to adapt your pick and place application to another robot with another design. Okay, so let's do it. This is gonna be equal. Okay, then the approach is let's copy the main and let's see what we need to modify. Okay, this is the name of the node that is gonna be universal 5. Then we need to spin and start. Then we are creating a planning scene interface, very important to allows to spawn, let's say, the table, the object, so that describe your environment. Let's think this planning scene interface object as a word in Gazebo. Okay. And then this is the most important thing, and the move it planning interface, move group interface. This is gonna be the planning group that we have set up when we have created our move it setup assistant package. And if you remember, the arm we have called it manipulator. Okay, then we are going to apply the add collision object that will contains the table and the object that has to be picked. And then here the most important thing, we need to pick the object. Actually, let's create, let's change the name, universal 5 pick group. Then we wait and then universal 5 place group and then shut down. Okay, so the main function is gonna be done. Then let's code the pick function. Okay, what I wanted to point out is that this pick and place application use extensively the object move it message grasp. So this object has, let's say, embedded a lot of functions like the post grasp retreat, the pre grasp approach, and the grasp pose. That they are very useful for simplify your life. So I would suggest you to use it extensively. Okay, again here, this is the position and orientation that we will need to change. What we're gonna do is to use the one that we have saved using the TF echo. Here we go. Then this is going to be the pre-grasp approach that somehow is going to tell how the end effector is going to approach to the object that has to be picked. And here we want to approach in the positive y direction. This is the reference base link from which these data are based to. Okay, and here is the manner where you're gonna deal with the post grasp retreat. So after that we have taken the object, we are gonna move in the positive z with this minimum distance and with this desired distance. Okay, so before to run this move group, we need to open the gripper and then close the gripper. And when we move the gripper, we are gonna pass this message grasp using the pre-grasp posture function. And the same way in the close gripper, we're gonna use the grasp posture function. So then we are gonna code the open gripper in just in a while. And then, okay, we need to set up the support surface as table 1. And then what we're going to do is to call the pick function to pick up the object. And don't make any mistake. This function is not this function here. Don't make a mistake. So the pick is going to be a function that is belonging to the object created here, to the object that has of type move it, planning interface, move group interface. And basically this function takes as input the object that needs to be picked and pass all the grasp function that you have set up and modified here. So this is a way that this function works. We can do it in another way, but we will see it at the end of this video. So now we can, let's say, code the gripper. Okay, then we need to modify this because this is the name of the gripper of our custom design. I remember you that the robotic gripper that we have set up in the last video, I'm gonna put the link of the last video in the top right corner here, has designed in such a way that is a mimic joint. So we will need to resize, so we need to command just one joint. So resize one, the joint name is gonna be okay. Then the position when the gripper is closed is gonna be 0 degree. So make sure to pass it in radians, and then the things here is gonna be the same, with the exception that we need to change the angle when this joint is going to be opened. And if you remember from the last video, when this joint is closing, when the angle of this joint is gonna be around about 45 degrees. So 45 degrees in radians is gonna be 0.78, I think. Okay, so before to test, we can take the add collision object, of course adapted to our case here. Here we are. Basically is the same of the other video, but with the exception that we have changed the dimension and the position. So here in this case we need to pass an object of type planning scene interface, and then everything is the same, and don't forget to add each object. Okay, I think that we have everything to test. So it's a good practice always to let's say to have a checkpoint here to check if we are running good. So then make sure to create an executable file of this C++ file. Okay, I want to remember you that when we are gonna close, this is gonna be around about 45 degrees. So in radians, this is gonna be 0.785. That's what we have hard coded, let's say here, when we want the gripper to be closed. Then let's change the planning group from gripper to manipulator. Let's go up. Okay, planner execute. Okay, let's test our code. So ros run the package, that is gonna be this one, and then UR5 pick and place YouTube node. Let's see what happened. Okay, the object collision is gonna be created. Okay, perfect. So it seems that at least for the pick is gonna be picked in the right position. It's gonna go in the pre-grasp position. Then it's gonna go in the positive y direction. It close the gripper, takes the object, and then it lift up in the positive Z. Okay, so the pick function seems to work. So this is a good milestone for this project. So now, as you may imagine, we are gonna code the place. But basically it's gonna be the same approach. Here we are, this is gonna be the place. So don't forget to put in the main. Okay, here we are. Basically, it's the same approach. So we just set the orientation and the position of the end effector in the place position. And then this is some kind of pre-place approach, and then we're gonna go down in the negative down z with this minimum distance and desired distance, and then we are gonna release the object in the positive x with this minimum distance desired distance, and then as before. And again, here this place function is belonging to a method to this class here, to the group class that has of type planning interface move group interface. Okay, so now let's test it, everything. Okay, let's see. Okay, is going to be approached, he picked, he lift, and then we are gonna go in the place position, and we go down, and we release, and we go in retreat position. Okay, so that's all for today. I hope that you enjoyed this video and you got a lot of value on it. And now you should be able to deploy any pick and place application with your own robot. This is gonna be a custom robot or a commercial one. Let's say a universal robot, Fanuc, ABB, no matter the gripper that you have, you just need to understand where is gonna be the base link, how it's gonna call the end effector. In this case, is gonna be tool 0, and how it's gonna be orientated and position related to the frame base link. And then you can easily apply this pick and place application. So basically, it's the same thing that we have done today. Okay, so before to leave you, I wanted to give you a task, a challenge, let's say. You remember that we have coded another pick and place application manner that I call it simple, which is not using the grasp function. And this is another way to do. So for example, the pick is gonna be easier, I will say. You just need to pass the orientation, the position. So basically you are asking your end effector to go in a certain position, and then close and go to the place position, and everything is related, is commanded here. This is another approach to code a pick and place application. So my task to you is to adapt this code here. I'm gonna the video that I made it is gonna popping up in the top right corner now, and so the task will be to take this code and adapt to your own robot, and in particular in our why not Universal Robot Model 5. So feel free to do it. If you have any problem, don't forget to reach out to me. Don't hesitate. And so if you like this video, don't forget to subscribe to the channel, and you can book a one-to-one discussion with me. I'm gonna provide the link in the description down below. And again, thanks for your attention, and keep learning robotics with Ross.